Very good morning. Welcome you all to the NPTEL online certification course on advanced distribution system analysis and operation. Today we'll be talking about distribution network reliability and specific to reliability matrices. Now, the reliability matrices are quantitative indicators that measure different aspects of system performances, particularly in terms of continuity of supply and adequacy of services. Now, these matrices enable utilities, planners and operators to evaluate the frequency, duration and security of service interruptions as well as the system's capability to meet the demand under normal and contingency conditions. Now, by analyzing reliability indices, stakeholders can identify weak points in the network, plan maintenance schedules, optimize their investments and improve customer satisfaction. Now, these matrices are broadly categorized into load point indices, which assess reliability at specific customer connection points, system reliability indices, which provides an overall performance view of the distribution network, energy oriented indices, which quantify the amount of energy not delivered due to outages. Now, let us start with load point indices. These indices quantify the reliability at individual customer connection point, also known as load point, that is where the consumers are connected. They are vital for understanding customer side reliability. So, for that we need to understand few nomenclatures like failure rate lambda, that is number of failures at load point I per year. Lambda I is the number of failures per year at load point I. We will move to average outage duration UI, that is average duration of outages at load point I in hours per year, and UI is the total outage time at load point I per year. Annual unavailability represented by AI, total hours the load point is unavailable in a year. It is essentially the same as UI. We will move to system reliability indices. This provides a network-wide measure of performance based on IEEE standard 1366-2012. The most commonly used indices are System Average Interruption Frequency Index, popularly known as SAIFI, which is defined as total number of customer interruption upon total number of customer served, that is summation of lambda I Ni upon Nt. Now, let us move to another definition of system reliability indices, which is System Average Interruption Duration Index, so called SID, that is the sum of customer interruption durations upon total number of customer served, that is summation of EY Ni upon Nt. Ni is the number of served customer of load point I, lambda I is the interruption, EY is the duration. Now, the SID, that is SAIDI, system average interruption duration index is considered the most common one to evaluate the system performance by calculating the sustained interruption of each customer in service area during determined period, that is either minutes or in hours per year. Now, the customer average interruption duration index, defined as CAIDI or KD, that is sum of customer interruption durations upon total number of customer interruptions, that is summation of ui ni upon summation of lambda I ni. We will move to one more definition, that is average service availability index, that is ASI, customer hours of available service upon customer hours demanded, that is summation NITH minus summation UINI upon summation NITH. TH is the load hours, which is 8760 for 1 year. The improvement of SAFES index level of the distribution system is the main goal to reduce the number of sustained interruptions that occurs in the power grid. Now, decreasing the KD index has the tendency to decrease the number of customers complaints. The KD's outage duration is 1 year and the ASI's available service period is mostly monthly or yearly. Now, when I talk about customer average interruption frequency index, that is KFE, that is the total number of customer interruptions upon total number of customer interrupted, that is summation of Ni upon Cn. The index gives the average frequency of sustained interruptions for those customers experiencing sustained interruptions. The customer is counted only once regardless of the number of times interrupted, and Cn is the total number of customers who have experienced a sustained interruptions during the reporting period. Average system interruption duration index, that is SIDI, defined as connected kVA duration interrupted upon total connected kVA served. It provides information on system average duration of interruptions. Now, moving to energy oriented indices. So, energy oriented indices, and these indices are very important to evaluate the load in the distribution networks. Now, the first one very important, ENS, that is energy not supplied. Now, used to calculate the total energy generated but not supplied by the system. That is ENS, which is summation of LA UI, where LA is the load at location I and UI is the duration of the outages. Similarly, we can define AENS, that is average energy not supplied index, that is total energy not supplied upon total number of customers served, that is summation of LA UI upon NT. What is NT? NT is the total number of customers served. Moving to one more very important indices, which is ACCI, that is average customer curtailment index, which is defined as total energy not supplied upon total number of customers affected. That is numerically summation of LA UI upon Cn. Now, one more important aspect, that is loss of load probability index, very popular, LOLP. LOLP is a stochastic method and it is used for specifying of reserve needs. That is, LOLP is currently being widely used approach by utilities for the assessment of the generation capacity requirement. So, what is LOLP? Which is the summation of Pi Ti, where Pi is the probability of loss of capacity and Ti is the duration of loss of capacity in percent. Now, if you define yearly LOLP, then yearly evaluation of LOLP are carried out in 4 steps. Yearly maintenance calculation of generation units and making a schedule. Creating capacity outage table for specific weeks. Calculating daily outages and summing days for weekly trend. Calculations can be done again for every week in a year. Now, if you focus on LOLE, which can be calculated from daily peak load change data, which has been shown in the figure 29.1, and as you could see, this is my peak load, and assuming that is the duration of loss, and this is probably the installed capacity, this is the reserve margin and capacity outages. So, for 1 year, that is for 365 days, we can plot a characteristic power, and for every day if you plot from peak to the off peak durations, and you can experience. All right. So, from the figure we can calculate the LOLE. Now, a specific outage of capacity assets the system with number of stochastic outages, existence and number of time units, and the calculation period can get weekly, monthly, or it can be yearly also. Now, LOLE is nothing but the summation of Pi times C minus L, that is Ci minus Li minus 1, where Pi is the probability of loss of capacity, L is consumption, and C is the power capacity. Now, loss of energy expectations, that is LOEE. LOEE is defined as summation of EI Pi, where EI is energy curtailed in scenario I, and similarly energy index of reliability EIR, which is 1 minus LOLE upon E, where E is the total energy demand over the evaluation period. For an example, assuming there is a a ghost town municipal electric utility company, that is GMEU, has a small distribution system for which the information is given in table 29.1 and 29.2. But all of you please remember, for any distribution system, if you have the information related to number of customers, average load connected, and the interruptions, disturbances, if everything is recorded, probably you can determine all the indices related to reliability smoothly. But just to demonstrate, we have considered one example, that is distribution system data of GMEU company, where you could see there are 4 different load points and number of customers at each connected point is given to you, and the average load connected is also known to me. And we can calculate that the total number of customers connected to the system is close to 1000, and the average load connected is going to be L, the total load, which is 10,100 as a sum. Now, similarly, if you move to the annual interruption effect, again load point affected 1, 2, 3, 4. In each and every point, how and what has happened to the customers to get affected. So, number of customers interrupted, they are actually 250, 200, 250, 250, and so on and so forth. And load interrupted kilowatt, that is 2300 at point number 1, 2500, 1600, 1600 in total going to be 8000 kilowatt. Duration of interruption, whether it is 2 hours or 3 hours or 1 hour or 1 hour, customers hour curtailed, and finally energy not supplied become totally 15,300 kilowatt hour. Now, what we will do with reference to table number 29.1 and 29.2, which is a very, very important indices, which is important not only for your assignment, but also for examination point of view. Assume that the duration of interruption is the same as the restoration time. Determine the following reliability indices. So, majorly we have 9 indices: SAIFI, CAIFI, SAIDI, CAIDI, ASAI, ASIDI, ENS, AENS, ACCI. Now, we can calculate what is CN, that is number of customers affected, which is going to be 250 plus 200 plus 250, that is 700 customers got affected. And then we can slowly calculate the SAIFI, which is 0.95 interruptions per customer served, CIFI, which is summation of Ni upon Cn, which is 950 upon 700, which is going to 1.357 interruptions per customer affected. We can also calculate SAIDI, which is summation of, just a minute. Yeah. So, we can calculate SAIDI, which is 1.6 hours per customer served. We can also determine CIDI, which is 1.684 hours per customer interrupted. Very, very simple. Once you remember the formulas, understand the philosophy, given the data, we can calculate all the indices easily. Now, similarly, we can move to ASI, which is 0.999, and ASIDI, which is 1.515 kilowatt hour per kilowatt, ENS, which is summation of L into R, which is 15,300 kilowatt hour, AENS, which is ENS upon NT, that is 15.3 kilowatt hour per customer served, and ACCI, which is 21.857 kilowatt hour per customer affected. So, all those 9 indices can be calculated for any distribution system where the load point, customers connected, if all the data related to customer and their interruptions are made available to us. Now, moving to reliability analysis method, reliability evaluation is classified into 2 main types. One is historical assessment method, which focuses on past outage data and customer discontinuous record, widely used by utilities to measure and benchmark current performances. It is also used to derive indices like SAIFI, SAIDI, CIDI, etc. Predictive assessment methods uses historical outage data plus mathematical models to estimate system performance under various scenarios. 2 main categories, simulation based method and analytical methods, are being used. Now, let us focus on simulation methods used to analyze large and complex systems that are too difficult for analytical models. The structure function, which uses Boolean logic to model whether a system is operating or failed, can be applied to series, parallel or hybrid logical structures. Complexity will keep on increase with number of components and configurations. So, we can see a series logical structure 1, 2, 3, 4 all are in series. We can also see a parallel logical structure with 1, 2, 3, 4 in shunt or parallel. Now, one more important method, which is Monte Carlo simulation, very popular, MCS, simulates component failure based on random sampling, provides probabilistic outputs such as probability density function suitable for nonlinear, complex or large scale systems. Systems where analytical models are difficult to derive can be numerical or analytical. Disadvantage requires large number of samples to reach accurate estimates. Analytical reliability analysis method, we have to do couple of modeling here. First is network modeling, which evaluates reliability by solving logical and physical connectivity, popular due to its similarity with distribution grid topologies, effective for evaluating connectivity loss scenarios. Markov modeling, which uses state transition models to evaluate system states, example, working, degraded, failed, suitable for distributed generation DG with stochastic behavior, and which can model two-state system up or down or multi-state degraded systems. Now, fault tree analysis, that is FTA, in which graphical methods using logic gates, they could be AND or OR, to trace how components failure led to system level failure in top event, which represents complex combination of failures, evaluates basic events like human error, hardware failure, signal error, etc. Two states Markov model, as you could see in figure number 29.4, an example of N state with derated states in the right hand side. Now, analytical reliability analysis method, in which we will also try to understand event tree analysis, used to identify accident sequence starting from an initiating event. If there is a problem, how the cascaded effect become sequentially occurs. So, which explores success, failure of safety functions and their effect on the system outcome. Complements FTA by analyzing post-fault progression, event tree development model process, where you could see the planned familiarization, definition of safety function, determination of system success criteria, and then moving to identification of initiating events and accident consequences, and we get the determination of planned demonstrate, and finally event tree evaluation takes place. So, with this we are coming to an end of today's lecture, and thank you very much. Just to conclude, very important part is about the indices that we have learned, 9 different indices and how different methods are being used to calculate those reliability indices. So, with this note, thank you very much for your attention. Bye bye for now.